This is a continuation of Chapter 4, Part 2, where we illustrate a few more problems involving probability. Supposing we know that the probability of a woman being red-green colorblind is 0.25%. So we say the probability of B equals 0.0025. But we are looking for a random woman that is not colorblind. In other words, we're looking the probability of B naught. To find B naught, we say 1 minus 0.0025, which equals 0.9975 or 99.75%, which means that the probability of a woman being not colorblind is very high. The important thing to notice is that the maximum probability is 1 and the minimum probability is 0. In other words, if something is definitely going to happen, the probability is 1. And if an event is not going to happen, the probability is 0. And then all the other probabilities are in between 0 and 1. Let's look at a table of accidents involving pedestrians being intoxicated, or PA, and driver intoxicated, PB. Notice that there is a combination of intoxicated or not intoxicated, and that the total number of cases is 985. Let's say we're looking for the probability of pedestrian intoxicated or driver intoxicated. In other words, the probability of A or B, which equals the probability of A plus the probability of B. The solution is to search the table and find all the instances of the pedestrian being intoxicated or the driver being intoxicated, and then divide the whole thing by 985. And in this case, it equals 0.41 or 41%. 41% of the time the pedestrian or the driver was intoxicated. Let's try the same thing again. This time we're looking for the probability of the pedestrian intoxicated or the driver not intoxicated. In other words, the probability of A or B naught, which equals probability of A plus probability of B naught. This time again, we search the table, find all the instances of A and B naught, divided by 985, and this time we get 0.92 or 92%. 92% of the time the pedestrian was intoxicated or the driver not intoxicated.